Hey guys, this is Stef from Samayas and welcome to my channel. Today I'm going to talk to you about this LogiLink PDU8P01. The good and the bad about this product in my personal experience. So this video is sponsored by me, myself and I. So what is a PDU? A PDU stands for Power Distribution Unit. You have a simple PDU like this one, or like the power block, where you can split a couple of plugs with or without a central power button. You also have the more advanced ones you can manage remotely, or those you can't manage, but where you can still see the power usage. So you have loads of different variants, from small to large. So why would I need a PDU? Well, a while back I decided to invest into a Dell R630 to explore Proxmox and migrate my production server from VMware to Proxmox, with the debacle happening around the Broadcom takeover of VMware last year. So first I got myself one server. Well, the Dell already has an iDRAC IPMI port, and so technically I can already remotely shut down or power on my Dell. So for one server, that doesn't make much sense. However, after a while, I got two more Dell R630s to play around with SEP. Then I also got a Dell R730 SFF with 24 SAS drives, and later on a Dell R730 XD LFF with 12 3.5 SATA drives to add SCSI to the game. Since I don't want to have those machines running 24/7 and they are located in my office basement, and I do want to be able to power them on or off whenever I need them, well, technically an IPMI port allows me to do that already, would you say? And of course, you're right. But for 5 machines, that still means that each machine is powered on just for the IPMI port. So in here comes the LogiLink. I did not want to spend loads of money on it. At that time, I found a device on Amazon that seemed the best fit for the features and price I wanted to spend. I paid around 150 euros. In my basement, I installed a small 8U rack on wheels, and this PDU just fits in on the back, with the rest of the servers taking up 7U. This device is larger than a small power block. It takes up 1U in space in the front or in the back and is roughly 15 centimeters deep. It's a perfect fit if you're willing to sacrifice 1U space for it. If not, there are other products that are better suited for it. Let's have a little look in detail. On the front, first you have a C20 power in, and then you have 8 C13s power out, which provide a total of 16 amp. There's also one UDP port and a small LED screen. As you can see, currently the IP address of the device is shown, which is 192.168.150.184. If I press the function button for 3 seconds, it switches to amp and current. So my device is currently receiving 227 current and is using 0 amp since nothing is plugged in, of course. If I plug a third time, as you can see in this room it's 31 degrees and the humidity is 32. And then finally you have 8 little LEDs. As you can see, port 4, 5 and 6 are on and all the others are off. When I first power on the PDU, however, to my annoyance, there was a static IP address assigned to it, and it totally ignored my DHCP server. The default IP address is 192.168.0.1. The default IP address is 192.168.0.10, and so you need to change your PC's IP address in able to modify the PDU's IP. After setting it up for a while, the PDU was working without any issues. But then suddenly the device became inaccessible, and not even ping seemed to work anymore. Of course, this happened on an evening when I was at home and couldn't do anything remote. The first time this happened, I discarded it as a fait divers, and it wouldn't happen again. However, after a couple of weeks, it happened a second time, and then a third time. After the third time, I decided to switch to fixed IP address, and after that, I didn't have any issues with it anymore. In general, I prefer to have all my devices on DHCP, so that I have one central location on my firewall to always have an overview of each device, and then work with IP reservations. Although this device does not have firmware 1.0 but is already at 1.0.7, I still don't have any possibility of upgrading its firmware. Another thing I noticed is that the RJ45 port is only at 10 megabit. My switch doesn't seem to have an issue with it, but some switches don't support it anymore. I do understand that having a 1 gigabit port on this device is a little bit overkill, but having a 10 megabit port doesn't make any sense either. So now let's have a little look at the internals of the device. When opening up the LogiLink PDU, you have 1, 2, 3, 4, 5, 6, and 7 screws, and then the top metal plate comes off. Inside you have 8 relays on one side, and the other side is just a neuter. So here you have a quick view of the back in the basement. Here's the front where the servers are connected, and here it's upside down so I can read easily the IP address. Now let's have a look at what ports are open on this LogiLink. Let's use Advanced Port Scanner to see what pops up. I already have the IP address since it's shown on the front screen of the device. So when I press start, what will show up? If I wouldn't have had the IP address, I could use my DHCP server if the device was in DHCP to show me. So it found the device and it found a number of open ports. Well, the only open port it really found is the HTTP port, which isn't really a lot. Well, at least the advantage of not having an HTTPS port is that you don't have any issues regarding security with SSL certificates 1, 2 or 3 or TLS 1.0, 1.1 and 1.2. Let's monitor the port for a bit. So I opened up my MikroTik switch and started a packet scan on the port connected to the LogiLink, and then I let it run for about 3 minutes. In those 3 minutes, I rebooted my LogiLink to see if I would be seeing any outgoing traffic. The only traffic you can see here is a switch sending ARP messages to the LogiLink. So at least the LogiLink is not broadcasting to any external IPs. So now let's have a look at the admin panel of my LogiLink PDU. I'm entering the URL of the PDU, which I've called logs PDU, instead of the IP address. So I made an entry in my DNS server to associate logs PDU to its IP address. When I press enter, it prompts me for a username and password. This device is very secure. It has as username admin and as password also admin. These days in Europe, it's even forbidden to either have a blank password or a default password, and each device should have its own password. However, this device is probably quite old and does not fall under those restrictions. So let's enter username and password, and then I come onto the first page. I can see in the top layer it shows PDU. Maybe they did an attempt to enter some logo somewhere, but nothing's there. And we seem to have a top bar where we have the total load. Currently no devices are connected, so indeed it's 0. Again, I have a temperature of 32 degrees. I have a humidity of 29 degrees and I have a status of normal. Something I did notice is when we looked at the LED display, we also had the voltage. Somehow here we don't see the voltage which is currently going through the device. And if we look on the left side, we have a kind of menu. And then on the right bottom side, we have the page which is shown. So the first page he shows is, again, he gives some status about the PDU, about voltage warnings, about current warnings, about temperature warnings, and about humidity. So if we click on PDU, again, we have that first page. Now let's look at system. In system, it shows me the model. It shows me the firmware, but again, there's no way to upgrade this firmware whatsoever. I can change the MAC address, which might be handy in some situation. I can change its system name, but other than entering it here, it's nowhere displayed. I have an admin username and I have its location. I named it basement. I change it to basement 2. I press apply and nothing changes. It just changes the label, switching it back. Now if I do the same thing with admin, which is the username, I enter admin1. If now I refresh, it reprompts me because the username is not admin anymore, but is admin1. Admin1, password, admin. Let's switch it back. Now let's look at the configuration side of things. First, the configuration of the PDUs. As you can see, the device had 8 sockets, so I have 8 different fields, 1, 2, 3, 4, 5, 6, 7 and 8. And for each of those sockets I can define an individual name, so that I know that my first socket is this server, that my second socket is that server, etc. Today I know which is connected to what, but in 2 months I might not necessarily. The second column is the on delay. That's quite handy if for whatever reason, for instance, the first server is your SQL server and then your second server is your web server, there's no point in bringing on the web server if your SQL server is not fully booted. So a second scenario about the on delays is that by starting up individual each server one by one and not all at once, is that it prevents you from autoloading your electricity network. The third column is the same scenario but for off delay. However, there I don't really see the need of it. But again, there's probably a scenario. Next up is the threshold page. Here they have made some attempts where you can enter some warning and some overload values for your system and eventually trigger warning messages. However, other than this page, there is no way, and other than the status on top of the page, there is no way for the system to communicate that there's some problem with the system. From my point of view, are rather useless. The only thing which is really not useless is the voltage overload. If for whatever reason your system should receive spikes over 300, then automatically the sockets will be shut down. So both the current and the voltage overload will physically shut down those sockets according to documentation. So the first step is that you have a current amp warning and a current amp overload. By default, they are set at 5 amps for warning and 6 amps for overload, which is strange because the documentation states that the device supports 16 amp. Again, I haven't tried those kinds of loads, so I have no idea. The second voltage, you have a voltage warning at 250 and a voltage overload at 300 volts. This is something I can play around with. Let's say I put my voltage warning at 200 and I for sure know that I'm around 230, you will see a warning. So here you see voltage value is above warning value. Switch it back to 250 and it comes normal again. The same thing for temperature. You could have a warning if the temperature in the room is under 5 degrees. In general, when a server runs, you really need to be somewhere in the Arctic to have issues like that. But let's say that if let's say I have 32 degrees, let's say if my temperature is under 35, let's generate a warning. Again, it's 33, so I get a warning. Let's switch back to 5. Same thing, if it's over 100 degrees, let's say it's over 30 degrees, I will get a warning. Again, it switches, but I can't really do anything with it. Switch it back to normal. Same thing with the humidity. Go from 80 to 20, since I have 29 of humidity. I will get a warning, but that's about it. So switching back to 80. Next page is a user page. At least here, you need to enter the original username and password and the new username and the password twice, not to make any mistakes. However, when we were on the system page, we were able to change the admin username without having to enter a password. So technically, if this system stays open somewhere and you're authenticated for I don't know how many seconds, minutes, whatever, a third party could come in and could change the admin user, even without knowing the password, which is not really secure. At least here they did the proper implementation, but somebody else could still screw up your username. Then good luck finding the username. So let's try to change it. Admin. Let's put it admin1, admin1, admin1. Let's press apply. If I do something now, I'm prompted again. Admin1, and I'm back in. Let's put them back to the normal. Admin1, admin. Now for demo purposes, I left username and password to admin. I haven't started with any complex passwords. However, I would advise using a very complex password. As you can see, and I will handle it in the next section, we don't have any way to lock out the device. There's no configuration and there's also nothing configured. And the final configuration now is a networking side. Here we can enter the host name. When the device is configured with a static IP address, it doesn't really make any sense. However, when it's in DHCP, that's the name it will transmit to the DHCP server so that you can identify the device. The second block is the primary and secondary DNS. Since this device really doesn't have any extra functionality to connect to whatever, there is really no reason to enter a DNS server or to use it. Now let's go to the socket control, the crème de la crème, why I bought this device. So here I can see the label for each of the sockets and I can see its status, on or off. Now let's quickly go back to the configuration PDU, because right now everything is on delay of 1. Let's put here an on delay of 5 and put here an on delay of 7 and put here an on delay of 8. And apply. Let's go back to the sockets. So if we want to change the state of a socket, we need to select an individual socket and then we need to choose the operation, whether or not it's on or it's off, or a recycle, which is on off. If we would like to do it on all devices, we can use the checkbox on the top and everything is selected. So let's power on the first. I want to power it on 1. I configured 6. I apply. I count to 6. Nothing happens. And it's on. The second is in 7. I apply. And it's on. The fourth one is just at 1, so it's almost immediately. If I want to switch them all off, I click on off, and they're off. So that's about it about the basic admin panel. So let's see how we can attack this PDU brute force. Last night, while dreaming, I created the most complex hacking tool ever written. First, I created a C# console application. The first function I created is a detect authentication async, which is a method wherein I will try to find out what are the authentication protocols that this PDU is using. So at first I created a special HTTP handler not to allow .NET to automatically redirect to a page or whatever to capture the 302s and 401s. Then I create a basic HTTP client where I pass in the handler. I try to capture a response, and based on the response, I read out the headers to see what is the protocol he's using. So let's give it a shot. We get an authenticated. We put in a breakpoint. As we can see, we have a basic reel. So we're using basic authentication. Let's continue a little bit. There might be more. There's only one. So the console application is writing myself the basic authentication reel. So we need to attack the PDU in basic authentication. Let's continue. So next off, let's write the brute force attack method. That's quite easy. I create a loop for here, just to make it simple, from 1 to 1000. I compose my base 64 encoding, which is used by basic authentication, and then I write 1000 times that code. And whether or not we receive an unauthorized, we are either accessing or we're in. And at the end, after having tried 1000 times, we'll finally log in with the right password to see it's still working. So let's give this a shot. Let's start. Let's first remove this breakpoint. Step out. Press F5. As you can see, it's trying 1000 times. After having tried 1000 times, I have a breakpoint to test and to see if I can still log in. This time I have the right username and password. So after having tried 1000 times, we try with the right password and see the response. And we're in. For whatever reason, basically, that's not a good approach, because one way or another, after having attacked the device 1, 2, 3, 100 times, either the response should be to slow down, either the account should be locked, or the IP address, which is attacking, should be blocked. None of this is happening. So this device is not protected at all and is possibly brute forceable. Well, this code is just basic, and having a brute force attack is much more complex than that, but that proves that this device is not really secure. Let's go full developer mode. If, as a developer, I would like to access more like an API kind of situation, what do I need? I would like to know the load of the system. I would like to know the temperature, the humidity, whether or not there are some issues with the status. I would like to see which kind of sockets I have. I would like to have the status of each of those sockets, and I would like to be able to switch them. If we go into dev of this page, what do we get? The first thing we get is the main page is an iframe. And the iframe contains a second iframe, which is the bar. It contains a status iframe. And it contains a sub iframe with your left frame, which is the menu, and the right frame, which is each of those pages which are seen. So for the status, the base thing we would be interested in would be this status.html, right? So if I want to access my socket control, let's have a look at the URL link, and there we have control_outlet.htm. So if I type control_outlet.htm, I have that page. Now let's return to the main page and let's see what happens in the networking tab. Something we can clearly see is that there's a script somewhere running, which is called PDU.js, and that instead of updating each of those pages, he's calling a status.xml. So let's have a look at status.xml. What do we see? We see the current load, we see a normal status, we see a temperature banner, something like that, we see a humidity banner, we again see a status banner, and that's not really a difference between status 0 and status banner. And then we see outlet status 1, 2, 3 till 8, counting from 0 to 8. And all of them right now are off except number 7, which is outlet stat 6. So if I return, indeed, outlet number 7 is on. Let's create ourselves a beautiful management application. I created an ASP.NET Core MVC application, which I've called Admin Management in my PDU management project. And I've created 2 service agents. I have the PDU base service agent and I have a LogiLink service agent. My admin management application at this time will reference both the LogiLink service agent and the PDU base service agent. For some functionality, which is the more general functionality, it will just reference the PDU base service agent, but for some specific functionality, at this point, it would also reference the LogiLink service agent. Since at this point, I don't know which might be specific for this or any other PDUs and which might be more general functionality. So what are the most important points when you create a service agent? You need to have abstraction, you need to have encapsulation, you need to have separation of concern, and you need to be able to reuse and test your component. Abstraction for the LogiLink service agent is just hiding the complex logic behind simple interfaces. Encapsulation for the LogiLink service agent is bundling data and methods and restricting access only to the service agent. Separation of concern is dividing the admin management and the service agent into sections, with each part has a single responsibility. Reuse means that the service agent can also be used in a Windows service or a Docker component. Right now, for starters, the only thing I did was create a website. But in the future, I might also create a Windows service or a Docker image just for monitoring the device and then transmitting it to a database or something else, or logging agents or whatever, to be defined. Now let's have an in-depth look at our PDU-based service agent. This is sort of a base component which will be used by any future implementation of a future PDU service agent. So the first thing I created in there is an iPDU service agent interface. What I imagined there are the following 4 methods. So the first method, called getSockets, will first return a technical ID from the socket and then the label. The second, getSockets and state, will return the label and the state. The third, which I envisioned, is switchSocket, which will take a socket name, which is the label, and the new state of the socket. And the last, recycleSocket, will just recall the switch socket to power it off and on, but it's a specific method and we could put in some extra code in the future if needed. The next based object I imagined, I called PDU details, contains the PDU server address, which can be an IP address or an HTTP link, and a username and password. And then I also created 2 enumeration. I first have the socket action enumeration, which can switch a socket on or off. And I also have a socket state enumeration, which is unknown, on or off. Since at some point the PDU might not be reachable, and then I should display that I don't know the state of the socket. If we then look more in detail of the LogiLink service agent, there as well I created a new interface, iLogiLink service agent. In there I created 4 new methods. Right now I have no idea whether or not other PDUs will have that same functionality. If in the future I would develop this application as being a more final product, these might eventually move to the initial PDU service agent interface. But for demo purposes I separated both. So in here I created a getPDULoad, a getPDUTemperature, a getPDUHumidity, and a getPDUState. As you can also see, the LogiLink service agent also implements the iPDU service agent. Then my most important component is the service agent itself, which implements the iLogiLink service agent. And I've created an internal enumeration which returns certain things, which is a combination of what we saw previously on the status XML page. So if we go more into detail about the LogiLink service agent, I first concentrated about the easy methods, the get PDU load, the get PDU temperature, the get PDU humidity, and the get PDU state. For that, I created a download status page, and in that download status page, first I format my URL correctly when inserting my PDU address. The convert PDU status XML to enum string function converts the enumeration, which is more usable, to the field within the XML we previously saw. So here we see it again. We have current 0, we have stat 1, 2, 3, 4, 5, 6, we have humidity and temperature. If you go back to Visual Studio, you see that there's a 1-by-1 mapping of this function. The next function I've created is a more general download page where I have download LogiLink page. If you go more in detail here, we have a general function where first of all, based on the PDU details, we build the base64 username and password. And then we have a normal HTTP client which just receives and downloads in case it finds something. If nothing is found, it returns an error. Since this is a POC, at this point I did not bother to add extra error handling, etc. I've created this page separately from the first because we will have to download other pages as well. But let's again concentrate on the first page. So here, once we have the result, since it's in XML, we load the XML document and then we do a search specifically on the enumeration which is translated to the right value, and then we capture the inner element. As you can see, the inner element of 31, 28, etc. If we look at the constructor, it already receives a PDU details. PDU details contained the service address, the username, and the password. And this is injected through IOC. So next up, let's try to build a socket list. So first, what we try to do is based on the socket page, which is controloutlet.htm, we try to receive and capture all those details from that page. However, if we look back at this page, it's quite simple, right? We have the label and we have whether or not it's on or off. However, if we look more in detail, this page is not exactly that. We have a body, we have a number of TRs, that's okay. The first TR is our socket header, so we don't need that. In the next TR, we have in the first sub-TD element the label, which is the one we need. And then in the second element, we have a span ID, which is a technical name of the socket. However, at this point, we have an off, but this off is filled into scripting. And then we have a third label, which is a button to check it in or out. So when I look at it through the browser, the on or off is already filled in. However, after having downloaded the page and seeing what we return from the PDU, it's a little bit different. First, we have indeed TDU, the TD, and then we have the technical ID. However, this field is not filled in. So for this page to get the socket names, that's not an issue. But for getting the status, we will need to make a combination between this page and the status.xml page. Next off, the HTML page, if we go back to the view, as you can see, the first TD we need to skip because it's a socket name, it's the header. And it's not using a T-head, it's just using a TD. The last one also has nothing to do with the list, so we need to skip that as well. Once I have downloaded that page, I put it in the HTML document. The HTML document is a shared component, HTML agility pack. And once it's put into HTML document, I just run a select single node query on it, and I'm searching for one specific table. Since this is a specific document, I know there's only one table that exists. Once I have my table, I run again and I find all TR records. But then, as we've seen, we have the first TR, which is the header, and we have the last TR, which is the footer, which we don't need. So for that, I create a small function find socket ID and label from the R record. If we have a look in there, I just do a search and I see if my second TD element has a span. If not, I return a 0 and skip it. If it does, I just retrieve the span ID and the label. And then we run and we can see to the add watch window that we have retrieved our 8 sockets with each individual label. So now let's have a look at our get socket and state function. As we saw, the outlet page only returns the socket name and the socket technical ID and not whether or not it's on or off. So we need to combine this with the status.xml function. So first we call the get socket to retrieve the socket name and technical ID. Then we format the page to retrieve the status.xml. We call that, we load it again in an XML document, we parse it, and then based on the technical IDs we have in the socket list, we will for each of those sockets retrieve and call whether or not the socket is on or off. As a final result, we can see in the watch window our state and sockets. So as you can see here, the first one is on, the second one is off, the third one is on, the fourth one is off, etc. Something at this point which is not really so good. The way the implementation goes at this point is that on one side we have the download status page which handles the XML part on this side, which is used for the first for function, and then we have a re-implementation here in the get sockets and state. On one side it's a POC, on the other side there will be trade-offs to be made whether or not we have to call the status.xml multiple times and have a more general approach, or whether we would call it one time, work with a cache and or redistribute it. But at this time for this POC I won't go much more into detail. So for now, let's keep the switch socket and the recycle socket function, and let's have a little look at how we created our views. So in here, we first created the view model in which we have the index view model, where we added the socket and state dictionary, and then the 4 types, load, temperature, humidity and state as a string. Then I modified and created the index.html. The first div contains a little table where I display the load, the temperature, the humidity and the status. The second div contains a table where we loop through the sockets, where we display the label name, whether or not the socket is on, and we already have a little form in order to be able to toggle whether or not it's on or off. So let's display this for a second. Now if you go back to the HTML page, I already included a toggle button. The goal of this button is whenever I click on this, my status will go from off to on, etc. Since this is a POC, and since we've seen in the previous demos that if you press the on button there might be a delay, or if you press the off button there might be a delay, when reloading this page, potentially it might still show off even though it's already on. And so technically the same way as the application has implemented it through async calls, the status should be updated. For demo purposes, I have not done this. And so potentially, whenever I click a trigger, it is not shown immediately. So let's have a little look. I click on the toggle. Technically, nothing has changed here. It still stays in off. If, however, we switch to the original page, it shows it's on. We go back to the manager. We do a normal refresh and it shows on. So that's a bug which is perfectly normal at this time. So now how did I implement? I took a shortcut and I created a form for each of these buttons, which at this time seemed the best. So let's have a look back in the code. So I have a little form action, toggle socket, where I transmit and the socket key and the socket current value. So when I transmit that the system is at on and the backend code will switch it to off. So if we go to the method which handles that, I have a basic HTTP post, I have a basic anti-token validation, and so let's put a breakpoint here. So I receive a socket on, whenever the socket is on, so I receive off. So it's not on, so it's off, it will transmit on. Let's first have a look how LogiLink is doing it themselves. So let's switch off Dell number 2. After having pressed the on or off in the LogiLink admin panel, let's have a look at the debug window. And what do we see here? We see that instead of having a post, they are using a get method. From my point of view, using a get method to change a state is something which is not done. Get should be used to retrieve something and not to change something. It might create a lot of side effects. But then again, it is what it is and we can't change anything about it. So now let's look at the code. So first we have the switch socket function. It receives a socket name, which is the label, and it receives the new socket state which it would like to switch to. The first thing we do is retrieve the get sockets through the function we already implemented in the past, since we need to translate the socket label to the technical socket name. And the second thing is we do lookup to find the socket name ID. However, there's a little bit more of an issue. If you look at the status.xml page, we always have a socket name ending with stat. We can see that here in this private function. We have outlet stat 1, 2, 3, 4, 5, 7, etc. However, if we look at the two methods to enable or disable a socket, we have the following. It transmits outlet 0 to 7 and not outlet stat. So if you go back to the code, we need to find a clean way to remove stat. The shortcut I took here is just once I have a socket ID is to technically remove the stat from the word, and that's it. Now after having executed a toggle button, in the end the thing you see is he built a correct URL where the outlet 0 equals 1, operation 1 means off, and submit and apply, and that will switch off the socket. Next, let's look at the recycle socket function. In here, we call the switch socket, which we previously implemented. First we transmit an off, then we transmit an on. Potentially, we might have to put a sleep in between, or we could put in extra functionality in the future if needed. Now, let's have a look at our controllers. First, we have the home controller. In the home controller, in the constructor, we receive the PDU service agent. Again, IOC. Now let's have a look at the index method. The first thing we do is we call the get socket and state on the PDU service agent. This is a method which is implemented on the base interface PDU service agent. The next 4 fields are specifically only for the LogiLink, and so we check if our PDU service agent currently is implementing the LogiLink service agent. If he wouldn't be doing it, the next 4 functions wouldn't be called. Again, this is just a POC to show that we can call 2 different interfaces, etc. And then finally, we transmit all those fields to the previously created view model. Now let's have a look at the programs.cs. We had to set up some kind of plumbing. So this is again a POC and not some clean setup. The first thing we do is we add a PDU details. In there, we hard-coded the name of our PDU and username and password. In a professional application, that it should be coming from settings somewhere, from a database, etc. The password should not be in clear, etc. The next thing we add is we add a scoped PDU service agent with the implementation of the LogiLink service agent. And so we handled our plumbing. Then finally, we created a small API controller and some contracts. I first created a response contract, my sockets status, plural, which contains a list of sockets. Then I created the individual socket status with just 2 strings, socket name and the status. And then I have my API controller. Again, I receive the service agents to IOC. And then I have a simple get method which will return a JSON based on the result. Let's have a look at that. And it returns a JSON. So now we have completed our little POC. So as you can see, with a little bit of code, a little bit of hacking, a little bit of tweaking, we can easily replace the existing admin panel and extract some extra functionality which originally isn't there. So, is this device worth its money? Well, If you're a tech enthusiast like me and only needs cheap and small switching PDU, then yes, it does its basic functionality. If however you're an SMB, then no, this device doesn't have enough features and has security issues. If you are looking for anything more than basic switching, then this device is a complete joke. If you are electrically skilled, you could make a comparable device for a reasonable price with a good Raspberry Pi and a couple of relays and some soldering, as you can see from the inside video. There's not much more to it. Maybe that's a challenge for Jeff Geerling, to create as a perfectly Raspberry Pi powered PDU. When I look at it with my hardware hat on, it seems fine. When I look at it with my networking hat or my software hat, it's a complete joke. So what's missing in my opinion? For starters, HTTPS with custom certificate, brute force lookout, email notification or syslog, and an API endpoint. If you guys like this video, give it a thumbs up, subscribe to this channel, and hit the bell sign to stay informed. Let me know in the comments down below what do you think of this video.